Welcome to Advent of Code 2020 Day 7 and me C++ live coding solutions to these problems. So today's problem is about how many bags in this imaginary problem can eventually contain at least one shiny gold bag. The problem is that bags must be color-coded and must contain specific quantities of other colored bags. And then you get a list of these rules that tells you that a specific colored bag contains a combination of other colored bags. The problem, of course, is then to backtrack from bags that can contain shiny gold bags and then go upwards to their parents and their parents and their parents and see how many ways are there to carry shiny golden bags.
If you like my videos, feel free to do nothing. Just grab a cup of coffee
and enjoy.
So I decided to get these green parts as the bag IDs and get separate on contain and commas and dots or underlines and get rid of these blue words bags or bag, and then we get these small directed acyclic graphs with the parent bag and held bags. And if you assemble all the held bags upwards, you get this total acyclic tree, and the goal is now to count all the parents of shiny gold bags and count the parents only once. That's important. I missed that. So we create an Xcode project and get the in data, and I struggle a bit here to decide how to parse this, because the parsing of these sentences or rule entries are a bit convoluted, because if I split on cars, if I process them as characters, I don't get all the way, because I have to split both on commas and contain and get rid of bags. And so I go the deep route here, and we get 3 levels of while sentences here to get finally the bag IDs represented as vectors of strings. So each bag ID is, well, basically 2 words or 3 words, the green ones on the previous sketch I draw. And well, I just use brute force here and tunnel vision, so I get down to a bit of dead ends here. I tried the accumulate and transform, and then I realized I need the count if to try to count the, well, my first approach was to try to transform or count all the rules that had the shiny gold as a contained bag. I don't think that was especially a good idea, but well, I struggle on here, and here I add break out the rule to search for if a rule contains a bag. So the rules allows a bag if any of the IDs of the rule has all of the words in the bag ID to match in any of the words of the rule bag ID to check. That's a mouthful. Okay, carrying on. Some cleanup here, and now we want to try to generalize this, and I'm still stumbling on here because I'm scared of having to do this many-to-many. I kind of know here I have a many-to-many problem, but I want to still hope that I can find a shortcut. I don't want to go the full direct acyclic graph processing route here. And of course it turns out to punish me. It gets really really annoyingly complicated. So I try the recursive count here. So I start with count the parents of a child, and then I recurse this. I get all the parents, and then for each parent I do the same thing again, get parents of that parent and so on, and I just accumulate everything of this together. And of course, and maybe you already spot this, that in this way I can't remember what parents I have visited, and I can't check that I don't count the same parents twice. So when I finally end up here getting a result, it's too large because I count, of course, parents several times. You can see me here struggle with a compiler error, and I do what I always do. I comment out code until the error disappears, and then I re-enter code until I get the... Oh, there I got an answer. You did see that? So here I just go for it. I think, okay, let's hope for the best that this is the answer. So I enter it here, and of course I get disappointed because this wasn't at all the correct answer. So it's quite late in the night here, and but I spent so much time now, I want to continue, I don't want to give up. So I try once more, and first I think that, oh, perhaps I counted the golden bag itself, the shiny golden bag itself, so I have one too much. And I kind of convinced myself that that's the problem. Although, spoiler alert, it's not the problem. I do not count the first child or any child. I only count the parents. But I add a lot of logging here to try to figure out what's going on. And it doesn't actually help. And also the complexity of this problem shows up over and over again because logging these entries are painful. Okay, here I go for one less. And of course, that's also the wrong answer. So here I take a break and then I continue. So I had almost given up here and thought, no, I have to get my sleep and just give up on this problem. But I couldn't. I struggled on, and it's I think it's around 2 o'clock in the morning now. And I realize here, after thinking about it, yeah, I think I count the parents several times. And I just add a quick fix here. I also go to the wording of the problem to see if I perhaps misunderstood something, because it's not so easy to explain this kind of things. Anywho, here's the logging, and I'm start searching for multiple parents, and I realize, yes, that's a problem. So I just do a quick fix here. I add a global variable. You see that parent bag IDs, and then I just enter. I just put every time I search the parents of a child, I add them to this list and sort it, and there you can kind of have time to see it there. I realize, oh, we have multiple parents. So what to do? Well, I just decided to transfer all this to a set, the standard library set function, because that class doesn't allow multiples. So now I get 197 when I put everything there, and I go for that as the answer. Remember, it's late in the night and I just want to get this over with. And this time it was the correct answer. So this wasn't nice, and I'm not satisfied with how I solved this problem. I should have taken some time and do the drawings you saw me do in the beginning here before I started to solve this problem. But I cleaned the code up, and there you have it. Thank you for watching, and see you next time.
If you like my videos, feel free to do nothing. Just grab a cup of coffee
and enjoy.